you guys rely heavily on something called Unity. So, what is Unity? Why was that so useful for the simulations that you did in your book?
Well, Unity is actually a game development engine. And so if you
Mm.
think about when you want to make video games, and quite often they're complex 3D worlds nowadays, you don't want every time you're writing a game to have to write the physics system. Like if you want someone to be able to chuck a cube or hold a weapon or push a button, you don't want to have to program how something is going to arc and fall, how things are going to ricochet, how light works. So you
You
can
want the
use one of
wiggles
these.
to wiggle properly.
Yeah. You want to skip all that and you want it to be consistent across different platforms. So we get these things called game engines. And there are two really big popular ones, but there are a bunch of open source ones. So the two popular ones are Unreal Engine, which you might know is the thing that
Mm.
everyone used to make Fortnite, and most recently has been used for films, feature films, as they've got that volume technology that they're getting on, that they're making all these digital sets, virtual sets for films.
Oh, cool.
And their competitor is Unity, which is a game development engine that mostly is used for mobile games and is the one that like Pokemon Go is built in.
Hmm.
And I guess because their competitor had gotten into films, which is a bigger market than games, Unity was like, crap, well, we better find our second market. And they found out that people were using Unity to simulate their robots that they could then make work in a lab. So obviously, if you can simulate something in a computer, it can try things out and fail and try again and learn much, much faster than it would be able to in the real world. And better yet, you can parallelize it. So if you have a robot arm who's trying to learn how to pick up a cube and you're trying to do that with a real robot, that's quite difficult to do. You have to wait for that thing to try and fail and try and fail. But in a
Right.
computer, you can make a million of them that can try a billion times a minute. And people had managed to hack this together themselves. And now Uni decided to go whole hog and support it officially.
Yeah, that is one of the when I wrote my book Deep Learning Illustrated, the of the three main reinforcement learning engines that you could use, one was provided by OpenAI, another one was provided by Google DeepMind, and then the third was Unity.
Oh,
So even years ago, they were big in that space. So, what's the relationship between Unity and learning algorithms? Like, why is it that something for simulating 3D environments is so useful for training machine learning algorithms, particularly reinforcement learning algorithms like these robot arms that you're describing? So is this something to do? Is this relationship between Unity and these reinforcement learning algorithms, these learning algorithms, related to the way that Unity can represent things visually and spatially?
yes. So obviously, it makes the most sense if you're trying to simulate something that's trying to solve a visual or spatial problem, specifically if you're trying to make something that will be translated into the real world for a physical thing. So you want to make a robot that assembles cars. You would have to get the physicality of that represented in the environment that it's learning in. So you want the thing it's picking up to have weight, to be slippery, and all of those physical aspects are really hard if you're trying to make an abstract representation of that without a full physics simulation, which Unity has. But also, you can abstract kind of other kinds of problems into something visual. So, the really beneficial thing about Unity isn't just that it can provide a lower level of abstraction, like in the good way, in that like it's more applicable to the thing it's eventually going to do, but also that you can watch it. It's very easy to see when your model has gone
Mm,
awry or is doing something weird when you've got a physical environment that has cameras in it that shows you snapshots of what it's doing. When you're watching something learn, you can see when it's gone weird, which is often the hard part about machine learning is
that's
when
cool.
something started learning the wrong things, it's gone off the rails, but you're just trying to look at like a tensor graph and you have no idea.